Again, my name is Dimitris, and let's talk a bit about AI. Um, in this movie, the teenager got to play a game with a computer, and he was about to start a nuclear war. Um, and then, you know, someone saves the day, and the world is saved. But for me, that was how I started with computers. I was amazed by the idea that computers have intelligence and you could do all sorts of things with them. But soon we realized that computers were not that smart. For a long time, you had to tell them exactly what you wanted to do. And for the most part, AI in those days was things like you see the picture, um, programs written in Prolog or Lips. There were some innovations like Deep Blue beating Kasparov back in '97. But for the most part, when we talk about AI in that period, it seemed like science fiction more or less. But things started changing. The last maybe 15 years, there were various innovations like self-driving taxis, robots jumping and running around. For me, the most interesting development was happening at Google, where AlphaGo, this algorithm, managed to beat the best Go player in the world. And a bit after that, they used a new algorithm that learned to play Go just by playing on its own, starting from zero knowledge. And this one beat AlphaGo, that beat the best player in the world. And after 3 days of training, it was able to do that. They repeated the experiment with chess, and in chess, in just 4 hours, the program managed to beat every other chess program in the world. So that was impressive. And if you don't live under a rock, you've noticed the revolution that's happening with generative AI. You are now able to produce pictures like this. That this one has won a competition with prompting, and of course with ChatGPT. With ChatGPT, the genie went out of the bottle. Essentially, it's one and a half year after this, and the big difference was that with generative AI, the computer enters the realm of creativity, and ChatGPT brought this to the masses. So now everyone has access to it. ChatGPT broke every record of launching an online internet service in just 5 days. They had 1 million users. Um, a few things about LLMs, large language models. If you happen to don't know, we're talking essentially about two things. Um, we're talking about the foundation models, which are produced by large organizations that are able to take huge quantities of data. They read the internet and they pass it through a very big neural network with billions of parameters. This is the brain. And to do that, you need massive infrastructure, GPUs, millions of dollars. And with that, what you get essentially is this thing that is able to predict the next word. So you give it a sequence of words, and it can guess, what's the next one. Like if you say once upon a, you can say, once upon a time. Um, to turn this into something more useful, we go to the next phase, to the fine tuning phase, where in the case of chat assistants, it's necessary to provide like a large number of curated texts, like questions and answers, and you train again the base model onto those, and slowly it learns to mimic this behavior. It learns to be able to hold the conversation by using the knowledge acquired in the previous phase. And during that phase, you also do things like you try to make it helpful, honest, and harmless, so that it can avoid answering questions like, tell me how to make a bomb, um, things like this. So this is a continuous phase of training, evaluation, deployment, monitoring, retraining. You can repeat that, and supposedly this is what some people will want to do, to adapt the base model to their needs. However, this is all data science stuff, and most people are not data scientists, they are developers. And the developers, all they care for is that, give me an API to call, and that's about it. The intelligence becomes just a part of your application. It's just another API, but it's an API that has two characteristics that are particular. One is that it's completely stateless. So any conversation you hold with a model, next time you talk to it, doesn't remember anything. So there has to be a middleware that takes the previous conversation, adds it to the existing one, and it just keeps adding and adding. So when you talk to ChatGPT, there is a middleware in between that plays that role. And the other thing is this API is not deterministic. So you ask one thing, you get an answer. You might ask the exact same thing, and then you get a slightly different answer or a completely different answer. So you need to have ways to manage this complexity. And the truth is that you can do a lot with a generic model and maybe a bit of your data. So many people can actually, go about without retraining models, just by using a generic model and something called RAG, retrieval augmented generation, which is a fancy way to say essentially I'm augmenting my dialogue with the model with additional information that's relative. And because in this discussion, this context, you have a fixed size of how much stuff you can fit in, you need to find ways to be smart. So let's say you have all your documents. You cannot just send along the discussion all your documents. You need to pick those pieces that are more relevant to the discussion to help the model give an intelligent answer. So that's RAG. And in Quarkus, okay, we've looked at it in different ways. Initially you say it's an API, call the API, but the truth is that soon you realize that beyond a hello world, it's hard to do something more complex. You need something more, and this something more for us came when the LangChain4j project was launched in Devox, Belgium, last October, where my team was there. We saw that stuff, we got excited. And excited why? Because this library is a clean room implementation of the popular LangChain Python library, but completely, written from scratch in Java. And LangChain more or less mediates between you and the models, and you can abstract the different APIs, can abstract the different models. It can deal with all the complexity, like, the peculiarities of every model, and keeping track of state, parsing stuff, and also helping you implement those, more complex retrieval augmented generation cases. So you can think of it like it's the hibernate of LLMs, more or less. So soon we realized that, there's an opportunity here for Quarkus to integrate this library successfully in the project. So we worked very closely with the team, and we performed like a deep integration with the library. And very soon after this, event, we came up with our beta version of Quarkus with LangChain4j. Now, what's special with Quarkus and LangChain? The way we integrate it in Quarkus is seamless. So it's just what you use, just another CDI bean. You use it as you use any other library in Quarkus. The mode in which Quarkus operates, and I'll show you this later, with the development mode, where Quarkus runs in the background and it can respin itself quickly. It suits very well the way you make those intelligent applications. You have to try prompts and see what happens. So that works really well. In Quarkus, we replace parts of LangChain with things that work really well and are very performant, like our own HTTP libraries, REST processing. In Quarkus, everything compiles to native. you get nice warnings. You can make very small applications. And also in Quarkus, whatever you do automatically gets this enterprise feature. So unified configuration, you get metrics, tracing, auditing, all those you get for free. So if the demo gods are good with us, I'll take you into some examples to see how it really feels like coding with Quarkus. So to get started with Quarkus, you go to Quarkus.io and you say, I want to start coding. Let me get this a bit bigger. So in Quarkus, you get to this screen when you can pick the components you want. So for this example, I'm going to make a REST application just to have an interface to interact with. And then we will look for LangChain4j extensions. And you can see we found 12 of them. And the extension in this case is normally one of two things. Is either some LLM API you can talk to, like OpenAI ChatGPT, or some sort of vector database. So for our example here, I'm going to choose a popular LangChain OpenAI extension. And once you do that, you can just generate the application and download it. And that's it. So if I go back to my command line, I have an empty directory here, more or less. So let's unzip what we just created here. So change into this. So we'll start the ID. So the idea with Quarkus is, you get into the IDE, you start your Quarkus in the background. So you say here Quarkus dev, and Quarkus compile itself, and then it will start in this special, let's say, development mode, where it helps you do, very nice things. So let's say Quarkus starts here, and when it's ready, we'll get a message. And if I press W, I'm going to my application. So now I'm looking at Mark Quarkus application, and if I go there, this one comes with a endpoint that I can talk to. Hello from Quarkus REST. So if we see back in our code, this generated code came with this file here. So this is the service that implements the endpoint. And of course, the funny thing with Quarkus is you can make changes here. Let's say, if I say hello codeweek, and I save it, and I go back to my endpoint and refresh it, immediately you see the changes. So this is compiled for you in the background, restart it, and it's there for you to test. Now, other interesting things here is our dev UI. This developer console is there when you run in dev mode, and you get to see, like the different components that are included in the server. So there is a LangChain component here, which is fun because you can also try prompting right there in the dev UI. Let's say, show me a Java developer.codes under the Parthenon of Athens. Let's see. And since I have a OpenAI key configured in my environment, it picks it up. I don't have to do any configuration, and then I can get even a generated picture right here, writing Klingon or something. Okay, so let's go back to the code. Let's say we want to make our application a bit smarter. So let's add some code here. So what we're going to do here is I want to replace this default greeting with something smarter. So the way we do it in Quarkus is we implement something that looks like a REST client pattern, in which you register an AI service asking Quarkus, make me an implementation of this thing using LangChain and whatever model is configured in the application. So, and in here we can say, I want to have a method called greet that I want the LLM to, let's say, implement by the LLM responding to this prompt. And that's all you need to do. You can immediately use it in your code. So in my application, I can do, inject an instance of my service. I can replace this part of the code. Great. That's it. So if I go here and I refresh, it took a bit of time. So what happened now, I call this method, which called the LLM, and the LLM replied, hello, can I sit you today? So that's the stock answer you get from ChatGPT. To make it more interesting, we can make our service a bit more complex. We can do that by adding a system prompt. A system prompt more or less provides a role that we want the LLM to play. So we can say, I want you to behave like a professional greeter. Greet people as if you are and this is a real person. You can Google them, and they run a show where they greet people in fancy ways. So if I repeat my search, you get this fancy, greeting. Greeting to you from the Greeters Guild, my good Quarkus friend, blah, blah, blah. All right, let's make it a bit more parameterized. So instead of hello Quarkus, what if we had like here a name? And we can get the name from here. So let's go back to my class and Dimitris. So if I go back here, yep, now it knows how to greet me specifically. Dimitris. So we're 20 minutes into the presentation. Okay. So, so what if we keep adding some methods? So I'll do this. What if I want to implement a method to ask the LLM to tell me the time? And to test it, I'll just replicate this method here. I'll do quick and dirty path time. Oops. So I did a new method. Supposedly will give me the current time. And what happens at this point is that the LLMs, they don't have a notion of current time or place. So they tell you, oh, I'm sorry, as a language model, don't have ability to know the current time. So how can we help with the model with this type of problems? What you can do is you can give the model callbacks that it can use to do like different things. So in this case, let's put a new class. We'll use a new bean. That's a standard, like construct in Java, and let's implement here a method. That will return the current time. So that's all standard Java. There's nothing special here. When it becomes special is when we add this annotation here, tool. It's a LangChain annotation to essentially say that I want this method to make it available to a model. And to connect this method with our service, we have to do this here. Tools, we have to link the one class with the other. Creator tools. Okay. Let's restart Quarkus to clean state and see what happens. So we're going to ask the exact same question here. What's the current time? And now it knows the time. So how was this possible? Let's see how we can put some more light into the inner workings of this. Let's see how we can log requests. In Quarkus Dev, you have this nice viewer of configuration, and you can go there and just make changes. And those changes are persisted in code. If I look in my configuration here, you see those were just added, right? I didn't have to do anything. So if I ask the same question again, just to get some logs, if we look at our logs, you'll see that that was the first request I made to the model. Okay, so I called and asked, what time is it? But in the request, there's this extra metadata that says, I have also this function available, the function get current time. So in the reply, ChatGPT said, look, can you call this this method for me? I don't know the time, but probably this method will do the trick. So can you call the method get current time, pass these arguments, format, which I chose to ignore, and tell me the result. So behind the scenes, the same question is repeated, but this time we pass also the result of the call. So there's this string here that represents what we return from get current time. And then ChatGPT, having all this discussion and the result of the call, can go back and essentially provide the answer, which is what we see here. That was the answer. So let's try some other example. So this example was made with ChatGPT. Let's try an example with a local model. So switch code to this one. Here I have the exact same service like that I show you. But in this example, I'm not using ChatGPT, I'm using local Olama, which is running on this laptop while I'm doing the presentation. So if we do Quarkus dev, again, Quarkus is restarted. And I'll go back and call hello here and see what happens. Well, it's not there yet. Yeah. So it's starting. And I have somewhere here, this is the log of Olama learning in the background, so I can see what's happening. So Olama replied. So you see the replies are different. It's a different model, but it's all local. I didn't have to exit the laptop to do this. And I can try again. So it's not too bad. It took like second time took maybe 4 seconds. So you can play with models locally if you have like a decent laptop. And when you're here, in this example, I have also enabled metrics. So just by adding another extension in Quarkus, I can get metrics about what's going on here. So let's say greeter, AI service. Yep. I called it twice, and I've spent, the longest method took 10 seconds, and I've spent 14 seconds in this method, and you can get some interesting metrics, export them in Prometheus and so on. While there, let me show you also, in this example with local Olama, I'm also adding some standard microprofile notations. I have a fallback annotation. So I'm saying if the call to the model fails or times out, don't wait, call my fallback. So return a stock reply. And to emulate a timeout in my properties, I'd say, I have a timeout here and say, I'll make it really short. I'll make it 2 seconds. So if I don't get a reply in 2 seconds, go to the fallback. So 1, 2, you see? Now the fallback got activated. We have some more time. I guess I'll show you more. We have more samples here. I'll show you one last one, which is like the most complicated, and maybe we can leave a bit of time for questions. Let's go to samples. Okay. Quarkus dev again, very easy. So this is like probably the most complicated example you see today, and it demonstrates RAG, but the special RAG. In RAG, normally you'd use a vector database, but in Quarkus LangChain, we took it to the next level, and you can actually use like a normal SQL database. So what's this example about? Let's see. We have a file, CSV file containing the top 100 movies from IMDb with all the data here. And this is ingested into a database, which Quarkus will spin like automatically in the background in a container, in a Podman or Docker container, which hopefully has happened. And what happens here is it's very interesting. You can ask a question to the bot and say, let's say, can you propose a comedy for tonight? And it proposed Life is Beautiful from those 100 movies. But it's interesting how this works, actually. It's super interesting. So the query gets normalized and compressed, and then it's sent to LLM, asking the LLM, look, I have a database with this schema, and I have this, and I'm looking for this data. So can you make me query to pull from the database the relevant data? And it produces a query, and we query the database, and then we send the result of the query with the question to the model. It's actually easier to see that through the dev UI. So if I go to my dev UI, in my dev UI, I actually have like a chat window right in here. And in that chat window, I can also look what goes on the wire in the discussion with the model. So let's say, what are the top 3 action movies? And it comes back with, okay, Dark Knight, Lord of the Rings, Inception. This is the information I sent together with the question. So I have already queried for that, but how did I do that? If I go back to my code, you see here, I've asked ChatGPT to give me a query, and it gave me this query. Look, select movie name from the database for action movies, top 3 movies by rating. Isn't this amazing? So let's do a more complicated question. Let's say, where my WI here? Okay. Let's say I want the top 5 action movies sorted by box office. And I get the 5. Look at the query again. Action movies ordered by gross total. And I actually want to include also the box office amount. And I have the numbers here. So this is pretty amazing stuff. It gives you an idea what can you do and how to make it, very specific to use your use case. Since I'm here, maybe I'll do like another quick one for you. Let's say we have here a translator service. It's in Quarkus you can write scripts basically, like command line scripts. So cpcli translator examples. So using with very simple service like this one, let me show you here. Your translator, translate whatever I give you between the delimiters into this language, and a bit of code to handle the arguments. I can do things like I've created 2 versions, like a Java one and then compiled to native one. You have a bit of time yet? Yeah. And I can do questions like translate this French text file into English and just give you a translation. Well, this is the original file, if you don't believe me. I can also execute this in command line mode if I don't give any arguments. So here I can say Greek and a bit of French in the same sentence. This is an example, my friend. So really cool stuff. All right, I think I'm done with demos. Going a bit to slides, so you can understand this is a whole new world we're entering, and it's essential to learn all these new technologies and use them. There's all sorts of things you can do with this stuff. Of course, anything related to customer service, chatbots, booking assistants, learning utilities or education assistants, marketing, generate stuff, reduce stuff, summarize, figure out sentiment, produce structured data from unstructured data, get code help, translate, analyze, and so on and so forth. So the sky's the limit, but be careful. Whatever you do, use the superpower for good, because it is a superpower, and as developers, I think we have an extra responsibility to to do it right. So with us, I think I'm done, and I can even have like a few minutes for questions if you want one. I can see it in the chat. Oops. Oh yeah. Actually, there were some. Okay. How about tool functionalities open weight models? Tool functionality in this sense is just a glorified way to say I provide a callback. It's up to the model to figure out when and if to call it. That's all. I mean, there's no other special thing. Of course, this functionality is not supported by all the models. ChatGPT supports it, and it would be nice to have it in other ones. Advice: what you should focus on. I'm not sure what you should focus, but you definitely need to learn those tools the same way you would learn how to type, because those tools now will be everywhere. So you look at it as a productivity enhancement, if anything, but it will transform the way we work. Would it be possible to start a business with zero budget? Yeah, maybe. Why we don't switch to 4-day work? Oh, that'd be nice. What else? All right. Thank you very much for sticking around. I know it's late for everyone. And I have also a volleyball game to go to. Thanks for sticking around, and see you online or otherwise. Bye-bye.